That's about the case, about business case. That's something we want to avoid, especially in a business. We have customer. Maybe it's a company, maybe it's an individual. For example, in our company, I work in a trading company. So we are so afraid that losing customer. Because if we losing one customer, then we're losing the revenue from our customer. So we have to make sure the company keep doing business with us. In this case, it's called potential customer likely to not to pay off. Maybe they borrow money from the bank, right? Just like individual, they need money. They don't have enough money, so they have to borrow money from a bank. It's called loan, right? It's called loan. So we have to pay back the money from the bank. Okay, so if we cannot pay back or repay, maybe the bank have to do something like write off the account. So it's a defaulting of one phone bill or credit card balance. It's kind of action that the bank will take. So it's a business problem. Before I move to the models, I would like to show you an example. So please, you have to download the data and the workflow from the Microsoft team. Especially the first one, I would like you to download this one. Where to download? In the share folder. In the general, under the general, we have data set folder. So you need to download this one called Bank Customer Rec. Rec means regression. We download this one first. Okay, you can download this one. I would like to switch to another material for Orange 3. Also the same week of 12, this week. We have regression, right? So this one. So I would like to switch to this one. Because only focus on text, you don't have the practice. So I want to switch to the Orange 3 hands-on. Regression. Can you see my screen? Yes? Okay. Can you see my screen? Good. Okay. Select rows. Okay. Select rows. Bank deposit project exercise. This I prepare for you to use the regression widgets in Orange 3. So we like to predict the deposit amount for bank customers. So in this case, the target is deposit amount. Right here, target is the deposit amount. Based on their income and other features for the income, again, we call income is a feature, right? It's a feature. Other attribute also is a feature. Okay?
Can you repeat which is the payment
so you didn't see my screen share?
non customer the first one. That one. Yes.
Yeah, this is that one. Can you see my screen? Microsoft Teams. You can log in Microsoft Teams. System right here. Okay, this one you have download. Click this one. Yeah, click this one and join the meeting. Join. Now you can see my screen, right? this one sometimes just not show. You can just follow my screen. Okay. So again, so we like to do the prediction of the deposit value or amount for bank customer based on their income, or you can call it feature, or sometimes the statistic we call independent variable. So we have to understand data first. There's an overview of data column and their meaning. For example, we have customer ID. It's for reference. Sometimes we just the column for reference. We will call it what? How do we call it? Just for reference. We call it what? In only 3. We call it what? What kind of row? Row? What kind of row? For this column, this kind of column? We will not put it into the analysis, just for the reference. Okay, we'll give a name called meta. Right? When the column is meta, you don't put into the analysis or do the prediction. You just provide some information for reference. Okay, so the customer ID is metadata, or is for reference. And then we have gender, right? Gender, male or female. So gender could be a feature in our case. It could be a feature. And also the customer age, and this one also could be a feature, right? How about a region? Yes, of course, maybe this also a feature. But it's categorical. It's categorical for region. Okay, let's go to next. We have rank. Okay, rank. Customer usually have rank because they want to loan money from the bank. The banker have to evaluate their credit and give the customer a rank. The higher the rank, you can borrow more money from the bank. So it's kind of rank. So rank could be also features and also occupation. 1 to 6, and income, loan. Okay, loan could be also is a features. Already that the banker already loan the money to the customer. And the late payment, whether the customer has made a late payment, they pay the money back to the bank on time or not on time, late payment. 0 for no, 1 for yes. So it's also categorical. Okay, now take a look at the data set first. I have to share the screen with you, so I have to open the data set, download here. Did I download the file? I don't remember. Let me do it again. Download. Yeah, I already downloaded this one. So it's okay. So let me open it and take a look. The column. Okay, good. Now take a look at the column. So we have metadata is ID called number, and have gender of the customer, age, region, rank, and this one is occupation, and also income, deposit amount. Deposit I treat it as a target value or target variable. Target variable deposit amount, and loan could be a features, and late payment also could be a feature. Down below, I give this workbook. The first worksheet, I call it just training. Can you see the screen? Okay, right? It's called training. So I split data into two parts. The first part for the training the model. Training, okay, train the model. And then the next is called testing. So I select another 10 records for testing or evaluate the predicted model. So you can just click. There's another 10, okay, another 10 for testing, the training. Let me see again how many records. Around 189. Okay, 189 because we have to exclude the first row. First row is a heading, right? So total record it's 189 for training the model, and we have 10 records for testing the model. Good. Now don't save. Close. Don't save. Close. Don't save. Okay, good. Close. Now let's move back to the material here. Now, how to build a regression model? In order to do this, we have to input the data, of course, load or input the data using 5 widgets, right? Then now we have to specify the target variable. In here is income. I should say the target should be I have to modify. This one should be the deposit, not income. Deposit amount. Deposit. Okay. Deposit of relevant features. And relevant features are other features. Good. So the target variable is deposit amount for bank customers, and the relevant features that we can use to predict the deposit amount. And then we have to bring in the regression algorithm, or sometimes we just call it widgets. Okay. Widgets is an algorithm. Algorithm is a set of instructions that the computer can follow step by step. So then we train the regression model on the training set and evaluate the model's performance on the testing set. So 2-step train the model and then evaluate the model. And then we can interpreting the result coefficient. Interpret the coefficient of regression model to understand the impact of each features. For example, income, age, loan, gender. On the target variable is deposit. Okay, that's good. Then we evaluate the model using the R-square to assess model performance. Okay, now. What kind of information you need to interpret the result when you use regression? What kind of information you need to interpret when you use regression? Anyone? From the correlation, then we move to the regression, right? Okay, let's go first, this one. Correlation. move to the regression. Sophie, we have clarified idea about correlation, right? You have idea about this one. We could be a positive relationship between x and y, or negative, or even there's no relationship between x and y. But when we move to the regression, what does that mean? What we want to test, or what we want to find out between x and y. What we want to find out between x and y? It's correlation or something else. Anyone? Would you like to share your understanding? Okay, when you moved from correlation to regression, what are we trying to do? Predicting, okay? Of course, now we talk about the predict model, of course, we predict value. So predict, and what else? Predict means to predict using X, right? Predict Y, right? Using X, predict Y. Not only to explore the relationship, but we want to move forward to predict Y. Okay. Okay. So now, what kind of information we will interpret or report when we have the regression result? What kind of information we need to report? Anyone? Regression, or you just forgot all of it? Really? Because suppose here we have x and y, so what kind of information we need to report?
The relationship.
Okay, the relationship in terms of what? We have to be more specific, because in the report output we cannot see the relationship, right? You just have different name, but what kind of name? It will show in the report.
The value or the variance, or maybe the model fit.
Model fit, really? Model fit? Okay, good, model fit. What kind of coefficient we need to report? At least we have two.
The R square.
R square? R square is coefficient. Of course we have to report R square or adjust R square. We have two, right? In design. Adjust R square. What about coefficient? What kind of coefficient? Alisa, Francis, Hazel, Viz. We have two, right? Two types. We have called intercept and slope, right? In here, this number is slope. Where is intercept? Where is intercept? We still use this scale plot to show the relationship. Oh, okay, positive one. Okay, this one positive one. Okay, and I would like to draw a regression line this time. A regression line. Probably here. This regression line. Oh, where is this intercept?
X0.
x0.
X equals 0.
Okay, good. Perfect. Yeah. When x equals 0, it's the intercept. Of course, usually you just see the result. You didn't report the intercept. You usually report slope. Then x inference y, right? So we have to report the slope. The slope is a coefficient. And what else you will report? When you use not only 2, 3, but maybe use SPSS, right? SPSS, or you use JEST, or use Smart POS. Okay. Except the slope, what kind of information you need to report? Oh. P-value, that's good. P-value, okay. I'm going to tell you one thing. Okay, one thing. Because the p-value or the p-value or the confidence interval, have you remembered the idea about confidence interval? Last semester, when we tried to test the mediation effect, we need to do the bootstrapping. That bootstrapping will create a confidence interval, let you know whether or not you have indirect effect or mediation effect. Okay. So they're based on kind of p-value or statistical value. But of course, in here, only 3 this kind of tool. Their philosophy is a little bit different from traditional statistical perspective. So even they have regression, but they does not report all the information, something like SPSS or JAS or Smart POS. So they just only report a very small of information, maybe only the coefficient or the slope. And how about R2? I'm not, okay, I will show you later. R square, of course, yeah, I have to read to see the, okay, let's keep moving here. Okay, now let's go into the only 3 part. You still can see my screen, right?
Yes.
Okay, good. So and I would like to predict a numerical value by using the regression widgets. Of course, we need the scalar plot. Scalar plot just something like on the right hand side of the whiteboard is a scalar plot. Then we can explore the relation between 2 variables. Okay. So this is a scalar plot for visualize the relationship between variables. And in Orange 3, that's called interactive visualization. What does that mean? It's something like if we have scalar plot on the screen here, we can manually select a small part of the data points. We can now the default is all the data set, right? Interactive means we like to focus on a small part of data set or the data points. We just use the mouse to select a small group of data points. Then we can send the report to the data table to view the result. It's called interactive. Just like something like what? Like Hazel, right? In the first section, Hazel tried to show the result of the group, the group by result. Because you select one row, you need one data point. So only show one. It's called interactive, right? In the OH3, allow you to do the interactive. You can select all of it or only select a small part of it. So it's called interactive visualization. Scatter plot. Okay, again, I think you already have some idea about this one. So scatter plot, we had to specify the x and y. As you can see, step 1, we have to select the x variable and the y variable. Second, if we want to change the color, we have more information we can specify about color, about the shape, about color of data points, about the shape of data point, and even the size of data point. And furthermore, maybe we like to show the label. You can do that in ONIX 3 scatter plot. Okay. So regression reaches there's input, okay, and of course there's output. Now there's a new terminology called learner. Now you can see that the learner is called linear regression learning algorithm, and the output is learner, a model, and the coefficient. You see that, the linear regression coefficient. But what does the learner? Because we call machine learning. Machine learn, so the machine itself is called learner. So the learner will be this one. It's a regression. You try to learn something from the data set based on their algorithm. And based on the data set specification, we have specified which one is a target variable and which one is featured. Then we can do the prediction, right? X and Y. So we learn something from our specification. And there's another keyword here called preprocessor. What does preprocessor mean? Anyone? Do you know what is preprocessor? We didn't mention anything about preprocessor in the previous course. Preprocess, right? For the process? Yes, of course, yes, for the process. For the data analysis process. Data analysis also is a process, but before we do the analysis, for example, regression, we have to do the pre-process of, or maybe to transform the data. Clean the data, transform data, but most basically, we have to do transform data to change something. For example, let me show you. Let me use this as an example. In our data set, we want to predict which target in our data set, which target we like to predict, which one, which column. Yeah, we want to predict the deposit amount of the customer in the bank, right? We can use the income, right? The customer income to predict their deposit in the bank. Okay? And this one is numeric. And this one also numeric, right? Or based on our previous course in applied statistics, usually I just give another name. It's called continuous. Continuous. And this one is also continuous. Or just for short, I just call it CO, or COCO. Okay, couple is not a drink. That in here we talk about regression, not couple drinks. Okay, it's couple, right? Continuous plus continuous. But here is another example. If I want to put the gender into this model to predict the deposit, and we have two values called female and male. My question is, can we do the prediction by using gender? We have gender variable contain two values, female or male. Can we put this variable into regression model? Yes or no? Not numerical, right? Yes. So if we do need to put the gender into the model, what can we do? It's already categorical. Change from, okay, we call this categorical, right? Categorical. Or we sometimes just say it's a card, right? CA means card. How do we transform the card into the continuous code? So then we can put the gender into the model, regression model. What can we do? Numerically, yeah, that's good. Maybe we can say that the transform the female into 0 and the male into the 1, right? Yes, good. So this called pre-processing. Okay. So traditionally, when you use SPSS, you have to do the pre-process before you do the regression. Yeah, but in order 3, they already include preprocessor. So he can detect if the variable is categorical, they will transform into the continuous. So it's automatically do the preprocess. So that's great. I don't have to worry about. But you don't. If you do not use the Oriented 3, you just write Python. Python is a powerful language. You can do anything, right? You can do anything. Even the YouTube channel, in a very early stage, YouTube channel was created by using Python. So it's a powerful language model. We can use Python to do the regression prediction, of course, but we have to write code. We have to do the pre-process by coding, right? Give the instruction, right, to do the pre-process. But now in Orange 3, because the foundation of the Orange 3, is Python. Yeah, the foundation of Orange 3 is still is Python. So we can, we know the creator of this package or this app, they already try to bundle some pre-process into a widget, right, and put into a regression widget, so that we don't have to do it. Okay, so it's called preprocessor. Okay, this is a linear regression screen. So as you can see here, we can fit the intercept, right? The first part, we can also give it a rank. Called the default is called linear regression, or the model, the predicted model is called linear regression. You can modify if you like, and then we have parameters. We can fit intercept. Then we have a small option about regularization. For traditional regression, we only select a default one called no regularization, because it's a general regression. And under no regularization, we have a more specific model called rich regression, lasso regression, elastic net regression. That's a different type of regression. Okay, but The default one is a traditional one, so we use the traditional one. Okay, so no regularization. Okay, pre-processing, I'd already just tell you the possible function, but in this here you can see that they even do the remove instance with unknown target value. Okay, if we have unknown target value, they just remove from the data set. And just like we say, we transform the categorical variable into continuous variable. And we have a special name for this kind of transformation. Special name called one-hot encoding. Okay, so it's only the people in data science or machine learning call one-hot encoding. But in traditional statistics course, people did not use this kind of name. Okay, they don't use this kind of name. But what does the people use? What kind of name do people use? Instead of one-hot encoding, in traditional applied statistics, if people try to transform the categorical into continuous, and then put into the regression model. And we have specific name for this kind of regression. We call dummy variable regression. It also is 0 and 1. It's called dummy. Especially for use SPSS. We don't have code one-hot encoding. You cannot find this kind of feature. Also in JAS, you cannot find the one-hot encoding, right? It's a traditional statistical approach. But in data science, machine learning, people use one-hot encoding. Just transform the categorical data into continuous. So different tasks, but the same task with different name. Okay. Now remove the empty columns or empty variable, and also impute. You can see that impute the missing value with the mean value. Right. So let's do a lot of work in pre-processing. Observe the coefficient. How can you see the coefficient? If we only put into the regression widgets, we cannot see the coefficient. It doesn't automatically give you the report, the output. So we need to bring in a table view or data table to view the coefficient. So that's called observing the coefficient. So now, okay, just stop here. Now I'd like to do the exercise. I have already prepared one example. You can download from the Microsoft Teams. You just move to the General tab, and you can find the Orange 3 workflow. Right? Just open Orange 3 workflow folder. This one. I guess I already put it here. Good. Now, at the bottom, you will find week 12 bank deposit. Okay, we just download this one. So let's download this one. Download this one. Okay. Good. And then you can open it. I want to close this one. Save. Okay. Okay. Now, good. Now this one is a regression model. Okay. Let me zoom in. make it more easier to read. Okay. So I will start from the left hand side. Introduce the data set again. So as you can see, the first one called file widget from the back. If you double click, now you can take a look. I want to show you that the file that I connect is the bank customer rec Excel file, right? But I have to specify the worksheet name called training, right? I use the data for training, and now you have to check the row of each column or each attribute. Make sure the deposit is the target. Okay, is the target. It's the Y or dependent variable. So with this one, and we have core gender 01. You see that? We have age. Okay, we have income, right? In numeric, it's a feature. So a lot of features we can use. We have loan, we have late payment. So almost contains all the column we have in the data set. Okay, good. So this is the first one. Okay, good. Okay, take a look again. Income age as feature, and deposit as a target. Good. Now let's take a look at the scatter plot. Take a look at the scatter plot. Okay. Now, Sophie, can you see the trend? Can you see the trend on the scatter plot? Yeah. So it's kind of positive, right? Relationship between income and deposit amount, X and Y. Good. Because you can see different color. If on the left hand side, if I select the attribute or color with the same color, will look like this. It's only as a traditional way, right? Only one color, so it's grade 1. So we have X income and we have Y deposit. So we can see that's our relationship, of course, that's good. So close it. So probably we can use a regression model. So I bring in the regression model, training. So now you can see the parameter. I just use linear regression. Okay. Maybe you can just modify this one. For example, I just remove the linear. I just keep the regression in here. Okay, good. And I fit the intercept and no regularization. Now take a look at the bottom. The original training data is 189. Yeah, it's the same in the Excel. Right? We already checked it in the training worksheet. It's 189. But the output, did you see? Only 3. Right. It means it output the coefficient. Okay, to the next widget. So now I have to close it. Now, okay. Let's see the coefficient first. Okay. Can you see now we can see the coefficient of slope, intercept, as you can see that, intercept, and we have income, we have age, right? The age 0.8 is for the age is equal to 1. Equal to 1. We have 0 and 1. In this case, 0.5 for the group of the value 1 in that age, in that Oh, no, I'm mistaken. It's the we have continuous. Okay, so we have a continuous variable for the age. So it's not the gender. I have to clarify. So we have only 3 coefficients report in here. But you cannot find the R square, right? You don't see R square in this result. And how about we bring in another called test score training data? This one. Okay, good. Now we have the R square. Right? Traditional in SPSS or JESP, usually will also have report the MSE or RMSE, right? But also the R square and adjust R square. But in here we only see the R square, but we didn't see the adjust R square. Okay, so that's the output. And if we connect to the data table. Okay, now that's the training data. Okay, let me ask one question. Let's see here. This is our feature 1 called age, and this is our feature 2 called income, right? And we try to predict the deposit. This is a target variable. Where is the predict value of regression? Where is the predict value of regression? Can you see? Can you identify? Huh? Which one? Which one? Don't worry. Regression. Okay. Yeah, that's correct. Yeah, that's the predict value of the regression model, right? Good. Yeah, don't worry about this one. So the deposit is original y, actual y. Okay, but the regression is actually the predicted value, or sometimes people just give y hat. Okay, y hat is a predict value. Oh, I'm afraid time is stop here. So we just review. We will revisit this result again next week. Okay, that's for it. Okay, see you next week.
Thank you.
You're welcome.